Let's do it. Okay. So hello, everyone. Welcome to this Zenity webinar. Today, we're going to be talking through some of the latest findings of the latest Zenity research report, the state of enterprise copilots and low-code development. My name is Andrew Silberman. I'm the Director of Marketing here at Zenity. I have the pleasure of being joined by our VP of Research, Inbar Raz. On today's session, we're going to walk through, what this research was, why we did this, what we set out to learn, what we expected to learn versus what we actually did, who and what we looked at. And then we're going to point out some of the trends and key findings that we found, including generative AI, guest access, authentication, secrets, oversharing, connections, and open source connectivity. Then we'll lay it up with next steps and maybe take some questions along the way. So the first thing, why did we do this? So to set the stage for the market, Gartner's came out with a couple of key statistics. They said, but first, by 2025, that 70% of new applications that are developed by the enterprise will use low-code or no-code technology. That came out last year. And then this year, they said by 2026, more than 80% of enterprises will have used GenAI APIs and or deployed GenAI-enabled applications in production. We actually think this might be a little bit light on both counts, and we're seeing huge volumes, both in terms of low-code applications as well as GenAI apps. We also saw from a recent Microsoft earnings call from Q3 of 2023, where they said that more than 36,000 organizations are already using existing AI-powered capabilities within Power Platform, and seeing huge numbers in the monthly active users of Power Platform. OpenAI is also up and coming in the space with over 150,000 distinct users and over 260 enterprise customers using enterprise OpenAI. Those numbers surely have risen lately in more recent times. So that's why we set out to research. This is an increasingly popular method of how applications and automations and copilots are being built. And we wanted to sort of take the pulse for how these things look today in today's enterprises. So the method to our madness here. So why, what do we set out to learn? So one, we wanted to see how organizations are using enterprise copilots and low-code development platforms like Microsoft Power Platform, Salesforce Einstein, Microsoft Copilot, ServiceNow, OpenAI, Google Gemini, and so on. We wanted to identify some key trends, and we wanted to look at at how large enterprises are facing these challenges, and what are some things that they're looking down the barrel of, so that we can raise awareness and that we can help improve security posture together. So the landscape, and then I'm going to pass it over to Inbar as well. But the landscape for why this is significant, it really to us kind of comes down to two things that we saw. For one, within the world of enterprise copilots and low-code development, there's no software development lifecycle that exists. So in normal sort of application software development, there's careful stages at each sort of checkpoint to make sure that software is being developed and code is being written correctly. When there is no code, there's no code to scan, and so you can't identify vulnerabilities that way. And then also just the speed, velocity, and volume of this application and software type of development just far exceeds, on purpose, the traditional software development lifecycle and CI/CD pipeline tools. These applications and copilots are also being built by business users of all technical backgrounds. It's no longer just IT or security or professional developers that are able to build these. The whole purpose of copilots and low code are to enable anyone to be a developer and build their own applications and automations and copilots.
And it's not only that, the main driving force of these platforms is to enable sharing and productivity. So it's not enough that you create something that is maybe not as secure. You're actually encouraged to share it with others, and by that increase the potential exposure of that same problem.
Exactly right. And we're going to actually get into that in some of our findings as well to show you just how large this problem really is. So what we found diving into some of this research, and again, this is mostly focused on large enterprises. So the first thing that we found was the average enterprise had upwards of 79,000 individual applications, automations, copilots that are built outside of the purview. So based on the size of the customer, it was actually about 0.8 applications that are built per employee. So, huge volumes of applications. There's lots of stats out there these days, but the one I saw most recently was from Okta, where they said the average organization with 10,000 employees has about 400 or 430 SaaS applications. Compare that with, at a 10,000 person organization, you're dealing with 8,000 applications based on this sort of research and scale. We also found that upwards of 62% of these applications had some type of vulnerability. And when we were conducting this research, we mapped these violations and risks to the OWASP top 10 for low code, no code. This is such a massive problem that OWASP has actually dedicated an individual project to OWASP top 10 for low code, no code. So the number one risk, and again, we're going to dive into some of these numbers and crunch them at a deeper level, but the number one was authorization misuse. And then you can see on the left-hand side of the slide here that authentication and secure communication failures, data and secrets handling, these are all major, major problems. All top 10 had over 1,600 individual violations that were measured. The goal of this research was to identify then where your most critical risk, because if you're staring down, 60,000, 70,000, 80,000 violations, it can be really challenging to know where to start. And that's, again, where some of our research was focused to help pinpoint some of these most acute challenges.
And now it's not only that, unlike the example of the SaaS applications are actually taken care of. Someone is the owner, they improve them, they patch them up. When it comes to low code, no code, and citizen developers, many times people just play around with it, create something, and then forget about it. Or maybe they leave the organization, but what they created is still there. No one is patching things up. There's no automatic mitigation. So it's possible that the vast majority of these vulnerabilities are not going to take care of themselves.
Exactly. So to dive in here, so Gen AI, unless you've been living under a rock, and even if you have, probably, you've heard that generative AI is the largest and most swiftly adopted technology in history. Organizations are still trying to find the sweet spot between how to fully leverage and capitalize on the use of Gen AI for business purposes. The early days, obviously, a lot of people were using it to write poems and, answer life's great questions. But we're starting to see this seeping into the enterprise in terms of how people are actually building things and, automating processes. And a lot of that is actually using Gen AI both to build applications, similar to how you might use ChatGPT to, again, write a funny poem. You can use, Power Automate or Salesforce Einstein or OpenAI to feed it a natural language prompt to have it then build an application. You can also sort of take it one step deeper. And through a lot of these tools, you as a business user or anyone of technical background can build their own copilots or AI apps, embedding GPTs and LLMs and greater AI technology into the applications that you're actually building. And we've actually found that the average organization developed over 2,600 of their own published copilots to help automate tasks and process data at the speed of AI. So, Inbar, maybe you want to take it a step further and walk through some of the things that you and your team found in this research?
Yeah, so in some organizations, you can see a huge spike of Copilot creation once the Microsoft Copilot was published or announced, and that was the November of last year. And many of those were created, and as I mentioned before, people played around with it and then left it. So there's a lot of unattended, still, valid executable code or processes or automations that just lurk around and might be executed by people or might not. There's no telling. It's also a platform that doesn't give you an easy visibility. Every user can see not even all, but most of the copilots that they're accessible to, those they created, those they were shared, but it's not all available at one place. So it's becoming really hard to control that. But some companies even took pride in what they did and talked about sophisticated business cases where actually empowering their users, their customers, to do things that used to be very complicated, like filing tax reports or some insurance claims. And it came to a stage where people would log onto a website and have a conversation with a Copilot, who at the other end of the data flow would interact with business data, and this whole thing is unsupervised.
And that's a big problem, especially when you're thinking about the power of Gen AI, where it is inherently curious and inherently training itself and teaching itself new things, accessing data. And if you configure these types of copilots and AI apps incorrectly, as so many people are doing, it really opens you up to a large set of new risks that, again, can go undetected. So one of the things that we found the most common was that 63% of copilots that people are building using these platforms were actually made publicly accessible to the internet. Now, again, in some cases, this might be correct and might be the right way to do it. You think of sort of a copilot or a bot that's built that's meant to help people navigate your website. But then you think about so many of these applications and copilots that are being built where they're meant to assist in internal tasks, whether it's a marketing copilot or a financial copilot or a copilot that's meant to assist your team over in France. All of these things are meant to be internal. And if you expose them to the internet, it means that anyone obviously can access them and poke holes in them and insert prompt injection, attempt to do rag poisoning and lots of different things to infect the data, as well as stealing your data and sort of taking it outside of the corporate bounds. So
Yeah,
Gen AI, a big risk.
that would even require people to understand what they're doing.
Yeah.
Many times the defaults by these platforms are pro sharing, pro public. Some of it has changed. We're proud to say that we have reported a number of these wrong setups to some of the platforms, and the standard of security has slightly risen. Today, you're a lot less likely to find your stuff going on the internet without anybody knowing, but still many of the defaults are not standing in your way to do harm to yourself.
Yeah, and I think one of the most glaring ones we highlighted on the bottom right of this slide, where building your own Copilot in Microsoft Copilot Studio, which also serves as the extension framework for Microsoft Copilot, the default setting for a while was to have no authentication in front of this bot. And we're going to show, some of the stats related to authentication in a couple of slides here. But this was a default setting where people had to go out of their way to, configure authentication properly, which led to 63% of these copilots having open access, no authentication, and just being sort of sitting ducks for bad actors. So if we shift territory a little bit here, it's all sort of on the same thread. All roads lead to sensitive data, right? You always want to be focused on your crown jewels. You want to focus on what the most important things are. And again, with lots of these, for a long time, people sort of viewed low code and copilots as, being fun little things that, people can automate tasks and, make their lives a little bit easier and all that stuff. But what it's actually turned into is people are building pretty powerful and critical business applications using these platforms without code. And so we found, so again, if you take the 79,000 individual applications, you narrow it down a little bit. And again, some of these other applications you still want to keep an eye on because they might be critical tasks or automation or rely on processes. But we found that nearly 11,000 apps per organization actually were configured to have access to sensitive data that also then contained a security violation of some kind. So Inbar can take a little bit through the story about why this matters and kind of how it happens. But again, this is usually a pretty good place to start from a security posture perspective, is to focus, again, what's accessing your sensitive data and where is your sensitive data then going? Is it being taken outside of the corporate bounds? Is it being accessed by people that you can't really monitor? Is, for guest users, which is, I believe, our next slide. All those things you have to take into account. And so usually we find this to be a pretty good place to start your attention with.
So one of the things we need to understand is that when you're looking at a particular environment, and let's just pick Microsoft because it's maybe the best example, all the capabilities that are being shipped out to customers, they all build on top of each other, and there's a lot of legacy code there. And all of the systems are basically on the same tenant. So when you're building a new Copilot, one of the things that you can do is use any of your already existing and configured flows and connections. But at the time of their creation, no one had any idea what Gen AI was and what the future potential uses for that would be. And a flow, as its name implies, is used to facilitate data flow. And maybe something was acceptable at the time of its creation, but all of a sudden, when you embed that inside a Copilot that is later shared, then all of a sudden you end up getting a multi-tool that was supposed to do one thing doing something else. And as we've shown before, with the example of the default no authentication, a lot of the defaults are pro sharing, and when uninformed citizen developers create these tools, they just do next, 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 next. And in fact, if you go now and create a new Copilot and you choose to enable the Gen AI, there's a little fine print that is really not highlighted, which says when you enable Gen AI, you consent to your data leaving your perimeter and geographical area. And this means that all of a sudden, citizen developers are making compliance breaching decisions, which the CISO would have never approved. But the CISO is not even in the loop and might not even know that this has happened.
And that's usually where a software development lifecycle or CI/CD tool or something like that would catch that type of error. But again, due to the nature of how these apps and copilots are being built, they're really just sort of being like there's no one's even aware, right? The old security adage, you can't secure what you don't know exists. That really applies here. And especially when you're talking about sensitive data, it becomes a big problem. So thanks, Inbar. That's really interesting. So our next, theme or trend that we noticed was supply chain risks. So supply chain risks have been, popularized or, sort of, notorious since, SolarWinds is sort of the last big example here. But there's a lot of supply chain risks that we noticed when looking at how applications are built using low code and enterprise copilots. So on the left-hand side, we show a couple of snippets from both MuleSoft from Salesforce and the Power Apps Component Framework Gallery from Microsoft. These essentially serve as open app stores where citizen developers, professional developers can insert pre-built components into their applications using drag and drop and really just embedding and downloading these files and inserting them into applications, reports, dashboards, whatever, to perform different functions, to connect to different data sets, to connect to different systems, to perform different triggers. And many of these components are fine and tested and tried and true. Many of them are actually open sourced. And so if anyone remembers the GitHub, sort of attack back in February of this year, where millions of malicious repositories were forked into existing GitHub repos where they were laced with malware or phishing attacks or bad links or anything like that that can not only cause you security issues but also disrupt operations. So one of the stats that we found was that nearly 2,000 individual applications contained open source components that were drawn in from these decentralized library, and another nearly 900 apps that contained custom code that's written by others, people outside of our organization that likely don't have our best intentions at heart, whether it's malicious or unknowing. And these could be contained, poisoned with malware, or could contain errors that leak data, or again, disrupt business operations. And this is a big attack surface, wouldn't you say, Imbar?
It is, and I think first of all, regarding the GitHub problem, this thing is so dangerous that code repositories even fool experienced developers. Uh, every other month, there's some example of some Python library that has been containing malicious code, and even the most experienced developers, didn't notice it. So if experienced developers fall for it, what will a person who has no software background can do, right? Nothing. And then you have the problem of when people created their library, they might have had a certain use case in mind, or a certain scenario. But just as we've seen at the beginning of this talk, where the landscape is changing so quickly, the assumptions that you made last year might already not be valid this year. So all of a sudden, taking a piece of code that was intended to use for a small use case and then embedded in something that has a huge scale or is embedded together with a decision-making algorithm, that changes the whole picture.
Yeah. And especially then you think about how the reusability of some of these components as well. If you're an organization and you insert, a specific component into, thousands of your applications or hundreds of your applications, and that one component is, sort of holding up the rest of your organization's infrastructure and, running these applications. If that component goes down, you have a single point of failure for a lot of sweeping challenges, both security and operations wise, that can become a big, big problem that, again, you want to be aware of what those components are, what they're built, how they're built into your applications, and then what applications rely on what components to sort of put together that type of risk matrix and business operations matrix for you as an organization, so you can just be aware of your risks and your single points of failure. And we've seen enough examples lately of single points of failure, platform players or agents being installed that cause all sorts of damage in supply chain. Obviously, it's a different scope and it's a different type of risk here, but it just raises awareness of, again, where are your biggest risks and what are your sort of single points of failure that could potentially, cause you damage. So the next slide here, talking about guest access. So guests or guest accounts rather, are ways of providing external users with access, usually limited, ideally limited access to internal resources. And that includes copilots, low-code platforms, and more. So last year at Black Hat 2023, our CTO and co-founder Michael Bargery gave a speech about letting business users build their own and the risks of guest access. So you provide a business user with a guest access account, and they are off and can build their own applications and automations, and again have access to these types of systems. And what he discovered in his research and in his talk was that if you provide, guest accounts plus a Power Apps license, it becomes a security nightmare, largely stemming from the shared responsibility model, where organizations are responsible for their underlying code, identities, runtime, the platforms are responsible for that, but the customer is responsible for their own data, the business logic, the access, the actual applications themselves, with very little visibility, because by definition, these guest accounts adhere to different security protocols than you do as your organization. And so providing these guest users with access to low-code platforms, it enables really anyone to build their own apps, to modify existing apps, and it provides them with pretty sweeping access that you want to be clear about. And so what we found in our research was that over 8,600 individual instances of untrusted guest users having privileged access to applications that are developed via copilots and low code. Excuse me, just 8,600 instances where they had access to apps that were developed via copilots and low code. 72% of those actually had privileged access, meaning they had unmonitored and unmanaged guests that can create, modify, delete any of these applications. And it's sort of been inherently blessed based on the type of access that they've been granted.
And this is not far-fetched at all, because a lot of the times what we've witnessed is people who work in organizations that do not provide the employees with laptops, they end up adding their own personal accounts as administrators to their own resources, which makes sense at the time, because these people can then fix problems when they're at home, when they don't have their company computer. But when that person leaves the company, even if the security protocol is perfect and HR is letting the admins know, and that person is being removed from the domain and all of their permissions are being revoked, their home address, their home guest account is still fully in control. And there's no visibility to that unless you go hunting for this.
That's exactly right. And one of the big problems that stems from that is then, sharing these applications and how, who you're sharing the applications and copilots that you're building. And one of the big problems is sharing applications properly. So as I mentioned earlier, many applications and copilots are actually meant to be designed for specific departments, use cases, roles, geographies, et cetera. So, think of an HR rep that's building an app to log HR activities. This, HR database might contain sensitive employee information, whether it's, pay scale, benefits, insurance selections, medical histories, things like emergency contacts, all that information HR kind of has access to. So who needs this information, right? Pretty much everyone except the employee it's themselves and the HR needs access to that application. But if you're then sharing that HR logging app, as this screenshot shows, to everyone in the organization, it is inherently probably a HIPAA violation. It's a GDPR violation. It's all sorts of different violations, not to mention that these are containing sensitive business data that you certainly don't want to get out there. And so this, due to both default settings and how these applications and platforms are configured, as well as sort of, I don't know, confusing code labels, like within the case of Salesforce Apex code. We found nearly 2,400 applications in our research that were shared to everyone at the organization, whether that's employees, guests, really anyone in the directory service or tenant has access to these applications. And again, in some cases, this is totally fine. But again, when you think about it, take an application that's shared to everyone, but also contains sensitive data. Think of an application that's, sending, has access to external users. Think of access to the public internet. These are all things where you want to be very careful about who you share these applications with. And, again, due to the less technical nature of who's using these tools, as well as the lack of checks and balances for how they're developed, it results in some pretty serious issues. So Inbar, the story I hinted at earlier was the Salesforce issue with Apex code, and there's a classification without sharing versus with sharing. This resulted in, Salesforce bypassing, really identity and access controls to share information with these Salesforce apps across the organization. Are there any others sort of that you can think of that you saw in your research for this report?
Yeah. First of all, I'd like to mention that today, if you create a Copilot and you share it with an individual, not with a group, that individual automatically becomes the co-owner. And that means they can do anything with the Copilot, including accessing all of the data that the Copilot can access. That is not something that needs to happen by default. If I have created a Copilot and I want to share it with my friends, they should have the ability to run it, but not the ability to inspect it or modify it. And that is not in my control. I can't even choose to do otherwise. Now, with regard to Salesforce, the combination of a few parameters can lead to a situation that we have both witnessed and managed to recreate in the lab, where unauthenticated users under certain circumstances will be able to achieve administrator status on your tenant. And of course, it's not out of the box, and it requires the user to make more than just one mistake, but all of the mistakes on the way to the disaster are naive and unintentional. And each and every one of them makes sense if you look at it on its own. But when you put them all together and when you understand the context at which things operate, then the disaster is just waiting to happen.
Yeah, it's a big scary world out there. And again, you're relying on people to make successive correct decisions in order to configure applications and Copilot security. And then even then it might not be good enough because you're sort of relying on the platform to guide you and help you make the right choices. And depending on the security posture and depending on what the Copilot is actually designed to do, you still might be exposing your data. And so again, you need checks and balances on the back end, of course, to fix these things. So, another thing that we talked about already a little bit, but to double click, authentication or lack thereof is very common in how these applications are built. And so again, we'll sort of pick on Copilot Studio here, where, you could see when you share your Copilot, after you publish it, you actually send that data, sort of across the tenant to the websites, et cetera. And what we found is that the average enterprise has 8,400 apps and copilots that either do not require end users to authenticate at all, or do so in an insecure way, whether it's a shared method, it's a username, password that are pretty easy to hack. Which leads us to our next point, where there's another 3,900 applications that either contain hard-coded secrets or contain an insecure step in terms of how it retrieves a credential from a secrets vault. Credentials obviously are everybody's least favorite and most long-standing, way of breaching into a network and provide easy access into your network and, providing, people with, ways in where they can move laterally and horizontally, where they can perform phishing attacks, credential stuffing attacks, all these different things. And it really speaks to the nature of how these applications are built and why they, how hard-coded secrets are so common. So any sort of things that you've seen in terms of why this is such a widespread issue in bar?
Yeah, because as I mentioned earlier, a lot of these things are actually legacy from maybe even before the organization was using a certain platform, or because some of the resources that are being used via what we call connectors, and we'll talk about that later, are outside of the what you will call the perimeter of the organization, whether that is a Microsoft tenant or any other environment. And so you are not always able to implement some sort of a SSO solution, or maybe the people that create these applications and want to add resources that they're accessible to, then without thinking, they just supply their credentials because that's what they normally do. And then maybe they're not even aware that these credentials later follow with the application as it is being shared. They just do what they always did, only now it's no longer only them. It's being shared with others.
Yep, exactly. And again, all this results in big challenges for security teams that are unaware that these applications sort of even exist to begin with, and then also are connected to sensitive data, and then are improperly configured to authenticate users to make sure they are who they say they are. So to kind of put a bow in this, tying it all together, connectors, it's sort of a neat little summary of some of the things that we found. And so connectors are really what makes things go, right? Whether it's a plugin for a Copilot, whether it's a data connector to bridge two disparate systems, whether it's a connector between, two different applications, all of that stuff needs to be accounted for. So one of the things that we found, and we ran research on this last year, where we found a list of connectors. We didn't find it. It's sitting there in documentation, where some connectors across these different platforms are actually unblockable, meaning security teams have no control of how they're used. And we actually found in nearly 8,000 specific vulnerabilities per organization, again, that relate to how applications are connecting to data sets. Some of the most common ones are listed here. And Inbar, I don't know if maybe you wanted to walk through a couple of these to highlight to highlight this point.
Yeah, so connectors are basically just the logic. It's the tool, but in order to be used, they need a set of credentials, and that together becomes a connection. And as we mentioned before, sometimes the credentials, they're hard coded, and sometimes one of the options that the platforms will give you is to use your own set of connectors or connections. If you already have an established connection, and again, a connection is an authenticated session. If I already have a connection to my SQL server and I'm writing an application using that, and maybe deliberately, or maybe just as I was developing it, but then it slipped my mind, I said, okay, you can use my connection because I already have it and it's working. And then I share it with others, then all of a sudden, everybody else who's using the application is getting it, my connection bundled with it. Now, maybe the users don't have the same level of access as I do, and maybe they can take advantage of some other vulnerabilities, like the IDOR vulnerability that you will sometimes find. And then all of a sudden, it's not just that there's another vulnerability that's being exploited, it is being exploited with my permissions or my credential levels, and the logging of this entire operation is under my name. So this generates a whole new set of problems.
Indeed, it does. You kind of see all the different challenges that emerge from how these applications, how the majority of applications and Copilots are being built nowadays, and it paints a fairly bleak picture. And it's really not our intention of doing this research, right? The first thing that I want to point out here is that, we are big proponents of this technology, obviously. This enables anyone to build their own applications. It enables new levels of productivity and innovation, and allows any organization to be on the cutting edge if they're harnessing the use of these tools properly. Innately, because organizations have big numbers of people that have all different technical backgrounds that leverage copilots and low-code tools in different ways. And we want to support that. And that was really the basis of this research, is to make people aware of the things that can and usually do go wrong, so that they can then take steps to secure it. In doing this research, the things that popped out to us were, again, that Power Platform, the Microsoft ecosystem, and Copilot and Copilot Studio were the most prevalently and widely used across organizations. Salesforce was a really strong second. We also saw, use and noted uses and use cases from ServiceNow, OpenAI, AWS, UiPath, Pega. They're also commonly present and are increasing in usage. I think this is similar to the cloud, where you're using different platforms for different things, and they're adopted by different people for certain niche use cases. Just that we found that Microsoft and Salesforce were the most commonly used, just due to how deeply embedded they are throughout most large enterprises. Obviously, there are lots of risks that people need to be aware of, but the first step in increasing security is being aware of these challenges. And so that was the basis of this report. And would encourage you, if you want to read the full report, to check it out on zenity.io. We'll send out the link to the full report for anyone who downloads and watches this webinar as well. Hope you found this to be very useful, and thank you for tuning in.
Thank you.
All right.
One of the things I think you should add in your closing argument